To prove the power law of logarithm, we can make use of its equivalent exponential form to do so. By letting log x base a to be m and log y base a to be n, in the exponential form, we will have a to the power m equals to x and a to the power n equals to y. Because this is as good as saying a to the power m gives x, a to the power n gives y. Using the law of indices, we can combine the powers of m and n by using the product of x and y. Re-expressing back to x and y, we will arrive to this equation, which is in exponential form, so we can convert back to its equivalent logarithmic form. So a to the power of this gives you xy. Rewriting, we will have the required form. In the exponential form, a needs to raise to the sum of m plus n in order to get the product that's on the right hand side. So similarly, a needs to raise to the sum of these two to get xy. With similar approach, we can prove the quotient law of logarithms. So let log x base a be m, log y base a be n. Converting to the exponential form, we will have a to the power m equals to x and a to the power n equals to y. Using the law of indices, we will have a to the power of m minus n to be equals to the fraction of a to the power m over a to the power n. So expressing back to x and y, we will have the following equation, which is in exponential form. So converting back to the logarithmic form, we will have a to the power this, which gives you x over y. So rewriting, we will have the required form. Notice how in the exponential form, a raised to the power of the difference m and n will give you the fraction that's on the right hand side. So similarly, in the logarithmic form, a raised to the power of the difference of these two will give you the fraction x over y.